In this session, we will discuss about gas. Now, you probably have also known there are several properties of gases. They expand to fill the volume of any container. They have much lower densities in comparison to solids and liquids. They have highly variable densities depending on the conditions, and they normally mix with one another readily and thoroughly, and they can change volume dramatically with changing temperature. Now you can imagine if you fill a balloon with gas inside, the molecules of the gas inside will exert a pressure into the wall of the balloon. And due to the speed and the collision by the molecules of gases that move around readily and randomly, we will have this kind of pressure, and then we can measure this pressure. There are instruments to measure the pressure, and one of them we call the barometer. The pressure itself is calculated by taking the force and divide it with the area. The unit for the pressure is normally ATM, Pascal, torr, or millimeter mercury. 1 ATM is equal to 760 torr, which is also 760 mmHg, and 1 ATM is also equal with 101,325 Pascal. In the previous session, when we discussed about stoichiometry, we've also discussed the ideal gas formula. And for this formula, you can see that if you multiply pressure with the volume, in which the pressure is in ATM and the volume is in liter, this is going to be equal with the mole times R, which is a constant, times the temperature, in which the temperature has to be in Kelvin. Now actually, the ideal gas equation that you are seeing now was derived from several gas laws. These are several separate different laws that at the end resulted in PV is equal to nRT equation. Now, based on several experiments, for instance, the Boyle's law said that if we have a gas and we have it at two conditions, but the mole and the temperature is constant, if we multiply the first pressure with the first volume, this will be equal to the multiplication of the second pressure and the second volume. On the other hand, the Charles law was derived from his experiments at the constant mole and pressure, and he found that the first volume divided by the first temperature will be equal to the second volume divided by the second temperature. There is also the Gay-Lussac law. At the constant now mole and volume, and in this case they found that the first pressure divided by the first temperature will be equal second pressure divided by the second temperature. And finally, there's the Avogadro's law that figured out that if instead we have P and T constant, the first volume divided by the first mole will be equal to the second volume divided with the second mole. These four laws together resulted in the PV and RT equation. So we can also see here that gas is the type of the phase that is very dependent on pressure, volume, and also temperature.